Okay. Okay. So today's topic is all about ACL, that is access control list. Okay. So ACL, access control list. Okay. Okay. So what it will do? For example, okay, access control list is going to allow or delay. Okay, delay is specific traffic. Okay, traffic, specific traffic. Okay, moving moving through the route. Okay, specific traffic. For example, okay, let's say I have one server here, that is server 1. Okay, server 1 is there. Okay, let's call this server 1 like this. For that, I have connected the router R1. I have two PCs connected, that is PC1 and the PC2. Okay, so what will happen? These PCs belong to some manager, and these PCs belong to some users, some regular users. Okay, here, since I connected to the router, both can able to send a request to the system. Okay, but what I have to do is I want to deny this users to access the server. Okay, so that one can be possible using the concept called. So using the ACL, I am going to configure in the router saying that we have to deny the packets coming from the users. Or we can say, let's say that I have IP address 192.168.1.1 and this is 2.1. Okay, so I'm going to deny a packet that is source as 192.168.2.1. Okay, so we are going to create a ACL. Okay, we are going to create a commands. Okay, what it is going to do? That is going to maintain the ACL is going to maintain the flow of traffic from the router or from one router to another router. We call this. And I'll give you another example. Okay, we can call this ACL also as packet filtering point, because what will happen? This router, whenever the request comes, for example, here the source address will be, example, this address will be like, let's say like 200 is this IP address like that. Okay, my source address will be 2.1. Okay, and my destination IP address will be 2.1, and my this one will be 100 like that. Okay, so what I'm going to do? I'm going to do 100. When my destination is 100, when it comes to the router is going to check the ACL. Okay, we are going to check the ACL in sequential order. Okay, there I write in a command saying that you have to deny any request which is coming from 192.168 or 2.2 to reach the 1.100. Then what it is going to do? It is going to check the packet. Okay, and it is going to check the case. Yes, as per the ACL, we have to deny that one. Then it is going to, this router is going to discard that. Got it right? So ACL, like the ACL looks like, got it right? This is the ACL, the main concept of ACL. Imagine that you came to the office one, you and some other guys came to the office. Okay, I created it. I told this one for reception saying that if anyone's name starting from one, okay, come to the office, you have to allow that. All other things you have to discuss. So when you come to the office, what will happen? They will going to allow, because if a name for a correct. The same thing it will be. I am going to create some rules with some names, ID, anything. Okay. So I'm going to create some rules regarding all those things. Then whether it is going to allow or not. Okay. This is how the real CCNA is. But when it comes to the routers, okay. So here what will happen? We are going to create some rules. Okay, so this is what I think you already done in RIP and all those things, correct? This one. Okay, so here what I'm going to do? See, this is 1.1. Okay, this is my 1.1 PC. This is another one is 2.1 PC. Okay, so let's say 2.0 network. This is my whole network. Okay, and I'm going to make this let's say 3.1 network as 3.1 as a file server or FTP server. FTP server. Okay. So what I'm going to do, I'm going to create a DNA saying that DNA 192.168.2.0 network, zero network. Okay, which is trying to reach the web server 192.168. So what will happen here? So when the request will move from here to R2 to R1, here I have given an ACL list. So what it is going to do? It is going to check. Oh, see whether the 2.1 or 2.2 both belong to 2.0 network only, right? Correct, right? 192.168, 2.0, 2.1, 2.2 like that. So what will happen here? So it is going to check the ACL here. Okay, it is going to stop that packet. So the packet it is coming. It is going to stop that packet and it is going to check that. And since it is matching the source IP address, okay, it is going to, and also we have to block the destination. Here the router is going to block. Previously, when you are using the RIP and all this is what happens. If you try to ping from packet from here to here, it's going to work. Correct, right? You've done RIP, AGRP, that's it. Remember, in the routing concept. Yes, sir. Okay. So same thing will happen here. When you try to ping from here to here, it is going to work. Now, due to some security issues, what we have to do? We have to maintain this one. For example, imagine this is a testing team. This is a testing team. This is a developer team. This is a developer team. And these tools are the servers. Okay. Here, what happens? Developers, once they develop the code, they have to go to implement in the server. Okay. Just a minute. Hello. ನಡೀತಾ ಇದೆ ಬನ್ನಿ ನಡೀತಾ ಇದೆ. Okay. So what will happen is this is the developers group and this is the test. Okay. So what will happen? These guys, okay, these guys are going to create a command and they are going to put it in the server. But the testing team, okay, this is a server. Remember, this is a server. Okay. But this is the another server only for testing. Like that, this is the server for developers. So what we have to do? I have to give this 3.1 access only to this 1.0 network. Correct? Yes. Right? And for testing team only to access 3.2 network. Correct, right? 2.0 can only have access 3.2 network and 1.0 network can only access 3.2. But when 1.0 network, right, access 3.0, I have to rename. Okay, and when 2.0 network wants to connect it to 3.1 network, I have to rename. Everything is going to implement on this router because where exactly is this? These PCs are located on this router. So I have to implement an ECL on this router. Got it? Yes, sir. Got it, right? So this is how we are going to use this one. And remember one more thing. Okay. So for example, let's say only these guys and these guys are talking to each other. Okay. And when 1.0, for example, this core team is a developer team. Okay. And this is the server team. Okay. When the developer team want to connect it to this server team, we have to give the access. And here only these guys wants to connect it to this guys. Okay. We have to give the another access. But what happens? I have the another router which is connected. Okay. Which will have the access of both of these. Then always remember this one. Whenever you give DNA option, so for example, if this is my router R1, this is connected to R2, and this is connected to R. I have this switch. Again the switch is connected. Here I connected two things. It is 1.0/24. This is 2.0/24. And this is 3.0/24. I'm going to first DNA saying that any messages come from 1.0 should not reach 3.0. Okay. But then what will happen in ACL when you are doing the ACL? It is going to check sequential route. Okay. If this becomes right, okay, it is not going to check the remaining things. It is not going to check. But here we have another scenario where 2.0 network wants to connect and able to connect 3.0, and 2.0 can able to connect to 1.0. Correct, right? Correct, right? I'm only denying these two things, right? I'm only denying these two things. Correct, right? But I'm not denying anything from R1 to R2 and R1 to R3, right? Correct, right? You have to mention permit any. This command, what it is going to do, it is going to allow remaining traffic. For example, when these guys send a message to, for example, R1 send a message to R3, it is going to disturb. But what happens if the R2 wants to send it to R1 and R3 wants to send it to, R2 wants to send it to R2 wants to send it to R1 and the R3 wants to send it to R. So what now? I have to permit the remaining things, right? These things can only happen when you give permit, because see, whatever the instruction you are going to give, it is going to check that one. I'll give you another examples like that. Okay. So for example, let's say that I'm going to take another example. Let me remove this one.
Hello, sir.
Yeah, tell me about this.
Sir, what is the ACL data address? I joined data late, sir.
Yes, Prakash, I'm reminding you each and every day, man. 6:30 means 6:30, Prakash. Please be online. Okay, because what happens, I can't sit for long time. Okay, say that is the issue. Okay, ACL means access control list. Okay. For example, Prakash, if you want to deny anything, for example, Prakash, imagine that. Okay, this is my developers team, and this is my testing team. Imagine these two pieces are server. This can only access the developers team, and this I have to make only access the testing team. Is it possible when you are doing the previous? No, right? When you try to ping, when I use the RAP and EIGRP like that, what will happen? If you try to ping from here to here, it's going to work. It is going to point from here to here, it's going to work. Correct, right? Now we have to deny, correct, right? Correct, right? We have to deny from this network 192 to 168.1.0 network to not access which one? 3.2. We have to deny 192.168.2.0 network to which does not access another 3.1. That means this 1.0 network can only access that 3.1 because this is I only made it for developers team. This testing team can only access this server only. This can be done using the ACL access control.
So, sir,
we are not only denying, we can able to allow also.
So, no, sir, we are denying only to the network of particular IP, sir.
You can do anything. You can do anything. You can able to deny particular network. You can able to deny particular PC. You can able to deny particular subnet also. Okay. Got it, right?
Yes.
Any confusion on this one? Access control is going to allow or deny this traffic in this router. Sometimes you may require like this. Correct, right? In this scenario, correct, right? They are in one network. What happened here? Just imagine you have a third router is connected to this one like this. Servers like this testing guy should only interact with 3.2 network, and this DevOps team can only interact 3.1. How is this possible? By using access controls. Here it is going to do the packet filtering work. For example, okay, now just imagine it only access this one, and these guys can only access this one. Okay, so I'm going to ping from this PC to this PC. Okay, so let's say that my source address will be 192.168.1.1 and my destination will be 3.1. Okay, since I've enabled something like RIP or EIGRP like that, static or dynamic like that, this packet is going to forward to this. Okay. The same packet is going to check the source and destination. Again, that is one plus t dot p. Since we already have the three-way handshake or something like that, okay, then it is going to forward to. Here I will implement the ACL. Okay. So here, what I implement, I'm saying that in any packets coming from 1.0 network, which try to reach, okay, oh sorry, allow or delay anything, allow 1.0 network to reach v.1. Then it is going to check this packet. What is the source address? 1.1. 1.1 commander 1.0 network. And what is the destination it has to allow? It is 3. Yes, it is a value. Then it is going to allow inside this. The same thing will happen in between this. Here, what will happen? This 192.168.2.1 network wants to connect to something like 3.1 network. But we have already given the DNA option here. DNA option I've already given. So what will happen? This packet is going to transfer to this. And here ACL is like a security. Who is going to check? Okay? And since I've denied this one, what it is going to do? It is not going to allow that. It is going to discard that. Got it? Got it or confused?
Yes, I got it, sir.
Got it? Okay. Now we move into the types of this one. Okay. Access list is divided into two types. Okay. One is numbered and another one is name. Okay. There is no much difference. And same. Here also there are two types. That is standard and another one is extended. Here also the same thing. Standard and extended. Okay. Here, what will happen in numbered ACL or named ACL like that? Here, for example, I'm going to write some ACL saying that here I'm going to write DNA 192.168.1.0 network to reach 192.168.3.1. Again, I'm going to DNA 192.168.2.0 network to reach 192.168.3.3. All these things are grouped together when we are going to form the case. Here, for this, if we give the number, that is 10, 20, anything like that, that is what we call the number is. Instead of this one, if we give the ACL with the naming convention, let's say CCNA or something like testing, anything like that, then this is called as name. Got it? Here the set of, got it right? Here the set of rules, these are the set of rules. Here the set of rules is defined by a number. Okay. Here the set of rules, okay, rules are identified by a D. Got it? Got it right? Imagine you have a group of this one is there. I'm going to give the number to them. If another group is there, I'm going to give the name. That is what the difference between number and name. Got it? Yes. Got it, right? Prakash, got it?
Yes, sir. Yes, sir.
Got it, right? Okay, fine, good. Okay, next we'll go the difference. Okay, both are same, man. Okay, so first we'll go to standard access list. Okay, standard access. Here the number and name both will be same. Okay. So here what will happen? The access list. Okay, access list. Number range is 1 to 99. Okay. So what will happen in this router? Okay, I'm going to give some name. DNA 192 DNA something. For example, let's say something like if you give the number ACL number ACL 10 and some set of standard instruction I'm going to write some DNA or allow like that. If this 10 is what you will get to know. Anything which come under 1 to 99, any number which come under 1 to 99, we call it as access control list. Got it? If you try to open some access list and you get the number 45, you will get to know that, oh, he is using standard access AC. Got it? If he is using 95 number, if you use something the name like number like 95 like that, then you will get to know this is anything which is from 1 to 99, if you give, that will become an standard AC. Why? Because the router is going to understand any numbers which is any access numbers which is given to 1 to 99, then the router will get to know the guy who is writing the ACL is using this standard access info list. Got it? Got it? Prakash, got it, right?
After doing the static hyphen list 100, that will be right, sir.
Which one?
When you are doing the static NAT, sir.
There you are when you're not static NAT, when you're giving the setup instruction. For example, I'll give you one. Okay, so let's say that deny. I'm going to use the deny command where, for example, deny. Okay, so deny 192.168.1.1.12 does not reach. Okay, 192.168.2.0. Okay, when it comes here, how we are going to write that? Okay, so how we are going to write this one? For example, so I can write it as, I'm going inside the router, I'm going to write it as, okay, access hyphen list. Okay, I have to give number 15. And then DA. What is that? This one? 192.168.1.1. Okay, so what is my destination? What is my destination then? 192.168.2. Here, what I'm giving? Number, right? Number. This number is going, then once you give this number, router will going to understand that you are using AC. But if you are using, okay, if you are using the number which is more than 19, okay, for example, if you are using the numbers like the DNAME, okay, access hyphen list, okay, 108 DNAME 192.168.1.1, and here is being 192.168.2.0 network, then it will get to know that 192, that is 100 to 100 extended ACL. Here, if your number range is 100 to 99, then it belongs to standard AC. Then your router, which is connected here, if you are accessing, if you are denying something you are giving, okay, access hyphen list number 108 deny bracket from 192.168.2.0 to 3.1 like that. Okay, here I am using 1. Then the router is going to identify this 108, since you will get to know that he is using extended AC. So see, look at here. That is what extended. Okay. See, if it is a standard ACL, it's like if any number which is comes from 1 to 99, then the router will get. If I use the numbers from 1 to 99, that will get to know that, oh, we are using the standard ACL. Router will get to know that the user who is going to implement the ACL, he is using the standard ACL. If I'm giving more than 100 to 90, 199 like that, the router will get to know that I am using the extended ACL. Okay.
Yes, sir.
Okay. Next concept is can block in network host and subnet. Okay, here in standard ACL, we can able to block the network host and subnet. What is the meaning of that one? Means we can able to block the network. Network means any network. For example, 192.168.1.0 we can call it as network, 2.0 we can call it as network, 3.0 is the network. Or we can able to block, not only block the network, we can able to block the host. Host means anything like 192.168.1.1 or 2.1, 3.3, 4.4, 5.5, anything. This is the single host. Okay, for example, let me show you. See, look at here. Okay, I can either block the whole network, or I can able to block the single network, single host. Okay, that is what the standard ACL will work. So either I can able to block a single host, that is this is the single host, that is 192.168.1.1, or either I can able to block the whole network, that is this whole network, that is 192.168.1.0 net. Or either I can able to block the whole subnet. For example, let's say this one I take a /24. I can able to block 192.168.1.0. Now we got it. Any confusion this one? Prakash,
Yes, sir. Yes, sir. What is
got it, right? The same thing will happen in extended ACL. Here, what will happen in extended ACL? Not only you can able to block the particular this one, that is network. For example, let's say extended ACL. In this one, for example, let's say I can able to block the network here. Here also the same thing. I can able to block the network, that is 192.168.1.0, 2.0 and 3.0 net. And also I can able to block a particular host, that is 192.168 or one network, 2.1 network, or 1.2 network, or 1.3 or 2.1. And also I can able to block the host, that is subnet. Like for example 192.168.1.0/24, or I can able to say 1.0/26 or 2.0/2027, like that. So not only this one, in extended we had another thing which is going to block is the service. For example, here what's happening here, service means, let's say this guy wants to connect it to this one. This is the FTP server. Okay, I can able to block the whole network to access this FTP server. Here in standard, we can only block the network host subnet. What? For example, here imagine this is a server. Okay, and it can only use for FTP access line. Okay, if anyone here from here try to connect this one, I can able to particularly block the FTP. Okay, sir, you may ask, sir, only FTP if I block, what will happen to this server? You can able to connect to another services, let's say www, that is HTTP, DNS, you can able to connect, DHCP, you can able to connect. Okay, syslog you can able to connect. Here I'm only particularly single service I'm going to block here. Understand? Understand, right? This is very important topic. I'm 100% sure wherever you go for CCNA interview, they are going to ask this one. Okay, which in extended ACL, not only it is going to block the network, host and subnet, the one main thing it is going to block is services. Here, for example, if this server, imagine this is a server, there are lots of services will be inside. That is FTP services will be there, HTTP services will be there. Okay, DNS, everything is there. Here, I can able to block this whole particular network or particular PC to access to only one or deny or access to one. For example, I can able to block FTP. What will happen if I block the FTP? Remaining I can access. For example, if you type here www.something 192.168.3.1, it is going to access. Here I'm just blocking only a particular service. This is the main difference between the standard and extended. Got it? Let me give you, I'm going to write. So for example, okay, for extended, okay, let's say deny 192.168.1.1, I'm going to deny here the particular host. If I'm denying the 192.168.3.0 network, here I'm going to block the network. If I'm deny 192.168.2.0/24, then I'm blocking the particular subnet. Including that one, I can able to deny 192.168.2.1 space FTP does not access a particular, I can able to be a particular services. This is the most important thing. Always remember. particular services we can able to deny in extended days. Okay.
Sure.
Hmm.
In in 2.1 holds the remaining except if everything can remaining service will be
Yes. Actually, remaining services should be. In extended ACL only see in standard either you block the whole thing or remove the whole thing. It's like that. If you block the one thing, it's done. Okay. See, for example, let me show you. For example, this is an standard ACL. This is an extended ACL. Okay. So what will happen here? I have these services. I have to rename. I'm going to take some example. Let's say 192, 168, 1. I'm going to rename it to reach it to 1. Okay. Then same thing I'm going to here rename. Okay. Uh, 192.168.1.1 to reach 2.1 only FTP. Okay, here what will happen? Here, if you have FTP, if you give delay, it is going to block in FTP. If you have HTTP, that is also it's going to block. If you have the ping, it is going to delay the ping also. It is going to delay the telnet also. It is going to delay the SSH. But here I'm just giving in extended ACL, I'm just giving the FTP. Here what will happen? It's going to block only the what? The remaining HTTP, ping, telnet, SSH you can able to. Now you got the difference. Cut it here. If you deny the whole this one, it is going to deny the whole services. But in extended, you can able to deny a particular services. Got it?
yes, sir.
Hello. Got it, right? Okay. So next is here we have two things. That is in standard ACL, we are going to implement it to the closest to the destination. Okay. So this means that for example, let's take an example like that. For example, let's say this is my nearest network. Okay. Here this guy wants to connect it. Here this guy and these guys wants to access this one. Okay, these guys want to access this one. Or I can take another example. Let's say that okay, this guy wants to access or deny this network. And then which is my source? This one will be my source, right? Because he's going to try to access this one. Then I'm going to implement closest to the source. Okay, in extended ACL, okay, we are going to apply to the router interface close to the origin of the traffic default because from here someone trying to ping, then this is my source address and this is my destination, right? Correct, right? Then I have to in extended ACL I have to implement near to the source. But when it comes to the this was standard ACL, if this is my source, this is my destination. In standard ACL, we are going to implement closest to the destination. That is, I am going to implement in the destination. But in source, we are going to implement here. Correct? But in destination, in this one, extended ACL, we are going to implement on this one. Got it? This is what the difference between these two things. For example, that is implementation closest to the destination will happen in standard ACL. If the implementation closest to the source, then it will be happened in the external ACL. Got it right? Got it right?
Yes, sir.
Okay. Now I have another thing. That is, for example, here I wanted to here in standard ACL, so filter can be done to the source aggregates. For example, here this is my network. Okay, so I'm going to block it. Okay, I'm going to block 14. For example, delay 192.168.1.0 network to reach something like 2.1. When any packets come to near this one, and here the router only checks the source address. It is not going to care about the destination address. In standard ACL, it only checks the source IP. Got it? Got it or confused? Guys, got it? Got it? Here only it is going to check the source IP address. It is not going to care about the destination, whether have to go for 2.1, 3.1 or something like that. In standard OCL, filter can be done based on the source IP. But in extended ACL, filtering can be done on source IP address, destination IP address, protocol, or we call it as port number. For example, I can say, here my source address will be DNAC. So 192.168.1.1. Okay, and my destination will be 192.168.3.1, and the port number which is going to block is FTP, or I can write directly 21 also. That is the port number. I can write FTP or directly port number 20. It is going to be. Here in extended ACL, it is going to filter. Okay, it is in source IP address. That is, it is going to check the source IP address, destination IP address, and which type of the services you need to. Okay, in standard ACL, what will happen? Standard ACL only checks the source IP address. But in extended ACL, it not only checks the source IP address, it is going to check the destination IP address, protocol, or port number also. This is one of the difference between this one. Got it? Got it, right? Nice. Prakash, go on.
Yes, sir.
Got it, right? Okay. So next is we have ACL logic. What is the logic? Okay. For example, so I'm going to perform like that. So saying that first I'm going to write DNAME 192.168.1.0. That's then I'm going to add permit. Okay, 192.168.1.1/20. See, look at here. Above what? Above what I did? So I denied 1.0 network, correct, right? Whole network, correct, right? But below I permitted this one, correct, right? It's not going to work like this. Remember this. It's not going to work like this. First you deny the whole network. After that you are permitting the another thing. It's not going to work. Either you have to permit first one. First, always you have to write the permit first. Like for example, permit 192.168.1.1, then deny 192.168.1.0. So what will happen here means, first if you give deny 1.0 network, what will happen? It is going to deny whole network. Okay, and again, if it comes to the sequential order, and then if you say 1.1, you have to allow the 1.1. It's not going to be possible because I already denied, right? Correct, right? The whole network is already denied, right? Correct, right? But here what will happen? Except 1.1 remaining will be denied on that side. So always remember, when you are using this one, you have to write it proper way in the sequential order. You have to use the simple common sense when you are writing the ACL logic, because it will work in logical, that is sequential order. Okay, once the packet matches, once the source and destination packet matches, the router is going to take action and it is going to ignore the remaining lines. So remember, always whenever you are giving that one, when you are giving in sequential order, you have to be careful. If the packet doesn't match, then it will go for second one. If the packet doesn't, if the this one, if the packet doesn't match or the ACL doesn't, it will go for third one. Okay, and if you go for fourth one or fifth one like that. If it is all this doesn't match, it is going to simply discard the packet. But what will happen here? If it is do like this, what will happen here? For example, this one I'm going to block to reach the RP, but I didn't give anything. I've given only the DNA 192.168.1.0 to reach the 3.0 network. And again, I'm going to DNA 3.0 to reach the 1.0 network. But here you have to use the logic. What is it? R2 can able to transfer the data from R1. Correct, right? R2 can able to transfer to the R1 and R2 can able to transfer to the R3. Correct. Correct, right? What will happen? So, something package came. Okay, let's say that R2 is going to ping. So, it is going to send a packet at 192.168.2.1 network wants to reach 1.1.2 net. This packet, when it is go to this one, it is checked the first one. No, it is not going to match that. This is going to, it will give this one and it will go for second. Oh, then it is not, Then what it is going to? There is no further, right? Correct, right? There is no further return. Then this packet will be destroyed. But as per 9, it has to reach the R1, right? Then you have to give another, this one called as permit any. Remember, permit any. What it is going to do, permit any. When these two networks are in between blocking or following something like that, these R2, whatever the other packets, when it comes to this R1 ACL, okay, it will check in the sequential order. If this doesn't match and this doesn't match, then remaining packets I have to block it. Block it, right? Yes. Because one. So it is got it, right? So you have to mention permit any because there are other packets in your network, they wanted to reach your destination network. So whenever you're writing the ACL, you should be very careful, okay, when you're writing this one. Got it? Okay, next we have one more thing. Okay, so I want you guys to interact with me regarding this one. So 192.168.1.0/24. Okay, 172.16.0.0/16 and 10.0.0.0/8. Okay, what is the subnet for this one? 255.255.255.2. Okay, 255.255.255.0. And for this one? 255.255.0.0. 255.0.0. Okay, good. Next, this one? 255.0.0.0.0. Okay, correct. Here, the three sets of 8 bits it's matching. That is ones. Correct, right? Correct, right? Yes. What is that? Here, the 8 bits. 8 bits. Okay, it's correct, right? It's matching, right? Yes. This is my network proportion, right? Right? And this is my host proportion, right? Okay. Yes. When you come here, 16 bits is my network proportion and remaining are host 0 proportion. So 16 ones I can call it as network. Right? Inverted comment from here, 8 bits are my network proportion. Remaining 24 bits are my host proportion. Right? Yes. But we had a concept called as wildcard mask. Okay, here wildcard mask is the reverse of subnet. Okay, so for example, okay, here we are going to use the wildcard mask in access control list to define which part of the IP address should be matched when visiting. So we are going to define which part of an IP address, okay, should be matched while visiting. Okay, so for example, 192.168.0.0/24. How are we going to write that one? 255.255.255.0. Correct? Correct. Here in wildcard mask, 0 represents network bits. 0 represents network bits. 1 represents host bits. But in wildcard. But in this one subnet, 1 represents network. Correct? 0 represent host. Correct? Yes, sir. Okay. So to get the wildcard, you have to divide from 255. So what is my subnet? That is 255.255.255.0. So what I'm going to get if I minus this one? 0.0.0.255. This is the wildcard mask. Here, what will happen when we are checking the wildcard in ACL? What will happen? This is going to ignore all this. This is going to check all these bits only. It is going to ignore the remaining thing. For example, here 192.168.1.0/24 network is there. It is only check this only. In wildcard, it is going to ignore the last one. If any IP matches to this one, it is going to block. For example, if 192.168.1.1 wants to connect it to 2.1 like that, here it is only check this one. Because here zeros represent the network, host represent the 1. Got it or confused?
Sir, please come again this one.
Okay, so what will happen here is, Prakash, imagine that you are going to the this one for garage. Okay, so in the garage you just have to change the oil. Okay, so what will happen? You just have to change the oil. Then what will happen? You are going to he is going to say that, sir, for oil changes we have this one will be free for free washing. Okay, and for regular checkup and everything is free. What you are going to do? It's none of your business, right? Your main work is oil change, right? Correct, right?
Yes.
Here the same thing will happen. Here I don't require all these things, because if these three things matters here, okay, that's enough for me. For example, see, I'm going to give another one. Okay, so let's say 10.0.0.0/8. I can write it as 255.0.0.0. But when I'm writing it in the wildcard, it will be 255.255.255.0. So I can write it as 255.0.0.0. So what I'm going to get? 0.255.255.255. Correct?
Yes.
Okay. So what will happen here? I'm going to only check the first this bit. Only in wildcard, this zeros is like a network. Okay, when router checking there, it only check this one. Remaining it is going to ignore. For example, if someone try to ping 10.0.0.1, okay, it only check this one. It is going to ignore all this. Everything will come under this one network only, but it only check the first bit. In previous one, what happens here? For example, here what will happen? 1 represent the network and zeros represent the host. Yes, here what will happen? Here 1 represent the host and zeros represent the network. So it only check the networks, not the remaining. Got it? Why? Because in ACL 0 is faster to check rather than 1. Correct? Correct, right? Right? Because lots of things will be transferring. If it is 0 means it is easy to check. 0 bit is easy to check. But when it is 1, we have to check all these things. For example, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0, not 0.0.0.0 like that. So if you want to calculate all this in how much? 2 power 7. 128 plus 64 plus 32 plus 8 plus 4 plus 3 plus 2 plus 1. Correct, right? So it will take some time. For me, it will take some time to this one, right? Calculate all those things, right? That's right.
Yes.
But what will happen in wildcard? What will happen? Everything will be zeros. Here I'm going to take network as zeros, and remaining thing will be ones. What will happen? If everything is zero means zero only. Correct? It's easy for the router to check all this. This is what the world. So remember, /24, I can write it as 0.255. Oh, sorry. 255.255.255.0. I can write it as subnetting. That is, this is the global subnet mask. That is 255.255. I can write it as 0.0.0.250. So I take /16 means 255.255.0.0. I can write it as, again, if I divide it this 255, 255, 255, it's gonna be 0.0.255.250. If I'm taking /8, then it will be 255.255, 0.0.0. Then I'm going to divide this into 255, 250. And it is going to be 0.255.250. This is what the wildcard mask. This was, yeah,
Sir, if it is /30, then how it will come out?
Then you do one thing. For example, so /30, how you are going to write?
255.255.255.250.
Okay. Okay. You do one thing. Wildcard mask, right? So you divide this one. What are you going to get? So let me ask you one thing. Okay, 255.255.255.252. 252. This is your /30, right?
Yes.
So if I divide from global subnet mask, that is 255, 255, and 255, how much you are going to get? Okay, so this one is up, this one is down. So 255.255.250. So how much I will get? 0.0.0.2. Correct? Yes, if I take, I'll give another example, /29. Then, if I use global subnet mask 255, 255, 255.255, then /29 means how much? 255.255.255.248. Okay, so how much is the remaining? 0.0.0. Perfect. You only check this network. This one will go to ignore. These three are the networks of wildcard. Got it? How to calculate? Okay. Next, we are going to define one thing, one use. Okay. Where I have to implement. That one I'll tell you when we are doing the move. Okay. So, for example, let me go through the line. Okay. So,
Wildcard mask which is used in only ACL.
yes, you can use it in ACL and OSPF also they are going to use because there are n number of routers will be connected. So what's the difference? Guys. Yes. Got it, right? Prakash? Okay. So okay. What is saying like here? I have three networks, correct? That right? Okay, this is 1.0 network. Okay, it's 1.0. This is 1.0 network. This is 2.0 network, and 3.0 network. Okay. So now what I'm going to do? Okay, let's take an example. I have to implement so that the packet. So let me go through this one. I just configure the IP address. So if I send a packet from here to here, okay, it's failed. From here to here, it's failed. From here to here, it's failed. From here to here, again it's failed. Now, what I have to do? Then the router is not able to implement any of the routing protocol. So I'm going to use the RIP now. Okay. If I use the routing protocol RIP, then what is this one? So router RIP network. What is the network which is connected to R1? Guys.
1.0.
Okay, good. Another
15.0.
Then, okay, here, if I add this one, router RIP here,
2.0 or then 11.0.
2.0. That is 192.192. Oh, sorry, it's okay. I know. Okay, fixed. Another one is 10.0.0.0. Another one is 11.0.0. Okay, here is RIP. Then 11.0.0.0 and 3.0. Right? So first I'm going to implement and check whether the packet is going to sending from source to destination or not. Okay. Let me go this one. I'm going to check the route of R1, CLR. Okay, so enable. Okay, first I'm going to do. Okay, so router. Let me take the now router name host 150. 150. Host name R1 and 150. Router RTP I'm going to introduce. So network 192.168.1.0. Another one is network 10.0.0.10. That's done on R1. Okay. Next we'll come to the hard CLI. When I didn't give the name. Enable 150 host name R1. 150 router RA. So what are the network? Network 10.0.0.0. Another one is 11. Internet network is 192. So 192.168.2.0.
Sir, we need to give interface IP address.
No. Nothing is required. Interface IP address is not required. Why are you required? I'm just telling the RIP. It's an RIP routing protocol. I'm just showing that I'm just advertising myself. What are all the things I have? Once I done RIP, yeah, tell me. I've given man. Everything is given. If I do like this, it will take up to 9 o'clock. Okay.
Okay. Good.
Okay.
No, sir, just asking.
Okay. No, I've already given. See, this already is done, right? You know how to do this lab, right? Because that's why I have to do it. I've already given. If I do like this, means I will take it till 9 o'clock like that. Okay.
No, sir.
Okay. So next, again here, enable on 50 host name RT. Then on 50 router RT.
Version 2. Version.
Yes. Okay. Router RIP. Version 2, anything is fine, man. I just want package to send from source to destination. That's all I want. You take anything. You take RIP, you take static. Okay. You take EIGRP also. That's not my problem. Okay. But the packet has to send from source to destination. That's all I want. Got it, right? It's not like I'm using the RIP means you don't have to use the RIP itself only. You can use the EIGRP, anything like that. Okay. You go network. What are the networks connected to RP? 11.0.0.0. Other than network 192.168.3.10. It's done. Okay, let me check the packets. The first packet is always done due to the ACL. Okay. Yes, it's successful. Okay, let me go to another one. Okay, it's successful. Send a packet from here to here. Okay, in progress, failed. Okay, wait. Okay, it's done. So they are pinging each other. So let me check here to here. This is successful. From here to here, it's successful. From here to here, successful. From here to here, it's successful. Okay, it's everything is done. Okay, now what I have to do, I have to implement two things. Okay, the first thing is Let me go and write it down. Okay. Not using this one. I'm going to use something else. Notepad is fine for me. Okay. So let me use another one that is important. Okay. Notepad. Okay. So here I'm going to delay 192.168.1.1 to reach 192.168.2.0. Okay. Another one is another thing. I'm going to deny 192.168.1.2 to reach same 2.0. And I'm going to deny another one, okay, another network that is I'm going to 3.0. So that is 3.0 network to reach 2.0 network. Okay, so it's done. And remaining things I have to make permit. Remaining package should be permit. Okay. So now, look at here. So what's happening here? Just a minute. Where is my pen? So what is the scenario here? I want to delay this 1.1 to reach which one?
2.0.
2.0 network. One is done. Another one is which does not reach the 2.0 network, but remaining has to reach this 1.3. If this try to ping, it has to reach the 2.1 and 2.4. Correct? Right?
Yes, sir.
Right. Okay. Next, another one is I'm going to deny 3.0. That is all this 3.0 network should not reach 2.0 network. What will happen if I didn't give remaining permit? Then what will happen?
Remaining species are not going to reachable.
Yes. So that's why at the end I have to give permit. Why? Because this 3.0 network enable to reach this one network, right? 1.0 enable to reach the 2.0 network, right? Correct?
Yes.
So now to open that one, we are going to give permit. And always remember, if there is you have to check your network structure properly, then only allow the access ACL. Okay, because if you're doing like this, okay, remaining package should allow. Got it, right? Let me go and implement. Okay, but where I have to implement? Any idea?
1.1 in router 1 sir, R1.
No. Where I have to implement the ACL? In which way? Either I have to implement on R1, R2, or R. Which one?
In R1 we need to deny 192.168.1.1 to 2.0.
That is okay. I cannot write here because there is a 2.0 is also there.
No sir, whole 3 networks need to deny here.
Yes. All this ACL I have to write it on some router. Which one? Either I have to write it on R1. If I write it on R1, what will happen? No. If I write it on R1, what will happen? If 3.1 wants to connect to 2.0 network, then who is going to connect? Who is going to check? If 3.0, here I write simply. That is that 3.0 wants to connect to 2.0. If you implement ACL on this one, here any package is going to check here only. And then what happens to the third one? 3.0 can able to connect to this one, right? Then
please.
No. You can only implement on R2 because all the networks are trying to reach which one? 2.0 networks. So I can able to do it on here. Prakash, got it or confused? Go on, Prakash. See, I'm asking the one thing, saying that you said, sir, you can able to implement this whole ACL in R1. I'm saying that if I implement all these things on the ACL one, then 3.0 and 2.0 can able to interact. Okay. And if you say that, sir, you will try to implement on 3.0 network, if you implement 3.0 network, then what will happen? 1.1 and the 2.1, 1.2 and can 2.2. I can able to access these two networks. Then this is not possible. This is not possible. Then here you check one thing. Each and everything is trying to reach which network? Which is my destination network. 2.0 network. And how to implement on this part? Got it or confused? Prakash, go on. Yes, got it right? It's a sense, right? I got it right. But now tell me one more thing. Nothing. Tell them.
Sir, yeah, for example, here, 192.168.1.1, I need to deny the 3.0 network. Then,
If I want to do it on the DNA 3.0 network, then what you have to do, you have to implement the 3.0. That is 192.168.1.0 network wants to DNA 3.0 network, correct? Right? Which is my source IP. Which one? ACL will only check the source IP, right?
yes.
It is not going to check the destination, right? So what it is going to do? It is going to DNA here only. What is? So as per the rules I told you, ACL source standard ACL only check the source IP, correct? Right?
Yes. Yes.
Okay. Okay, when you try to send a packet, the RIP is already exchanged the data between that one, correct? Right? So what will happen? When it comes to when I implement it here, the ACL is going to check the source IP. You said source IP is 1.0. 1.0 I have already implemented. Okay, you said 1.0 cannot reach the 3.0 network. First it will check this one, and this one, and block it will go to check it. If you deny here also, then it is not going to check the last one. Because here also it is already denoted from that one. To reach the 2 dot. It's 2 dot, right? Okay, fine. It is not going to do that. That is the disadvantages. Remember this one. Only it is going to check the source IP address. It is not going to check the destination IP address. For this purpose, what will happen if the 1.0 networks wants to deny 3.0 network, if I implemented on this one, what will happen? It is going to check only this 1.0 network. Okay, source IP only. It is not going to test the destination. For this disadvantages, we come into the concept of the extended AC. Okay. So, for example, as you said, you wanted to demo 1.0 to reach the 3.0. You have to write it in the beginning only, right? Correct, right?
Yes.
Right.
Yes.
So, you have to write it at the beginning only. And when you write it at the beginning, it will only check the source address. What is the source IP? 1.0. Correct, right? It is not going to move from here to this. It is going to check here and it is going to delay. Got it, right? Now, okay, everything is fine as of now. Now, tell me one more thing. Which interface I have to put this ACL? Whether I have to put it on serial interface 0/2/1 or 0/2/0 or FS0/0. Which interface I have to enable? ACL. Now you got it. Which router you have to do? Now I am sure that R2 is fine. Okay. So as for you guys, I got the one thing that R2 is the router where I have to enable this thing. But R2 has 3 interfaces. So which one I have to enable?
Sir,
Yeah, tell me Prakash.
Sir, in standard ACL, only source IP
is going to check it. It is not going to check. Yes, it is not going to check the destination.
Okay, but why you are not giving the source IP in ACL?
See, that is the thing what they have configured. For to overcome that one, they have come into the concept called as extended. When they introduce the ACL, the first thing what they introduced is the standard ACL. I told you that whole service is going to block in standard. That is why because of this. It is going to block the whole thing because it is only checks the source materials. It is doesn't care about the destination. That is the important thing. Okay. For example, see, look at here. If 192.168, if I say that 1.0 network, if you give 1.0 network, what will happen? It is going to reach say 192.1 deny 192.168.2.0 network. If you give deny like that, what will happen? It will be given to all the things, correct? Correct, right? So because it only checks the source IP address. If it's anything from 192, 168, 1.1, 1.2, 1.3, everything is come under 1.0. Okay. Because when it come here, it will only check the source IP address as per standard ACL. But in FTP, what will happen? You are doing the extra thing, that is FTP. So what it is going to do? It check the source IP address, destination IP address, and the port. So if not here, it only check the standard ATL because this is the standard ATL. They were first introduced that one. Because of all these disadvantages, they move into the concept called standard. Got it? Prakash? One. Got it. Got it, sir? Prakash? Yeah.
No, sir, but you told you need to enable the ACL in RT server.
Which? See, if I enable the R2 router, because all the, which is my destination network here,
2.0 network.
then, yes, even though if I enable this one, if I try to ping from here to here, it is going to possible. From there, if I try to ping from here to here, which is my source, 2.0 network. Correct, right?
Yes, sir.
Okay, so it is going to what it is doing. Then it will do this one become my source IP address. Right? I think I confused Prakash.
Yeah, yes, sir. Yes.
Got it, right?
Yes, sir, got it.
Okay, so now tell me one more thing, guys. So which interface? You got to answer that R2 in RT router I have to enable this. But on which interface I have to enable this? One more thing. Now, 1.1 is coming from here and here, and it's entering here, and you have to give. Okay. One more thing I forgot to give. Whatever the packets is coming inside the router, we call it as inside. Whatever the packets it's leaving, it is called outside. Not only this one, we can call this one as an outside. Okay. Packet entering into the router, we call it as inside. Packet leaving, it's called outside. We can call this one also outside and this one also outside. Got it? Guys, if any packet is coming from this side, okay, it's coming from this side, this is become an inside. Hence, it is leaving the router and coming inside the fast Ethernet 0/0 or to the switch, it is called outside. And if any packets is coming from here and reaching the source destination this one, then from here it is inside. And if it is leading from this interface and going this one, that is called as outside. This interface we call it as outside because it's coming from here and leaving. Leaving means not reaching, it's not like leaving. It's coming inside. Inside and outside. Got it? Now tell me where I have to implement the R1. So, to give one example, see, 1.1 also wants to interact with 2.0 network. 1.2 also wants to interact with 2.0 network. So, I can able to imagine that I can able to give it on 0/2.1. But there is another one is there. That is 3.0 should not enable from here. Then for these two things I can give 0/2/1. First two, this one is fine. But the third one, 0/interface 0/2/0 is fine. So everything, all the packets are coming inside this one. That is, this is inside and this is leaving outside. Okay, the packets, all the packets are coming inside this one. So I'm going to configure the ACL on FA 0/0. Got it? Prakash? Bhuvan? Yes. Prakash, you there?
Yes, sir, I'm there.
Got it, Prakash?
Yes, sir.
Okay, now let me go and try to implement. Okay, so okay, so I'm going to give any number, ACL number, any ACL number. So I'm going here. I have to config the is here. So enable config t. Okay, first access icon list. I'm going to give the number. So if I give any number between 1 to 99, that's a 15 I'm going to give. Then it's getting going to get to know that 15 is my standard ACL. So I have to rename which IP 192.net. So 192.168.168.1. Okay, another access icon list 15. I have to rename. Okay, you can give or directly rename a particular, or you can give post also. Okay, post is particular. Either you can give directly this one, or let's say 192.168.1. Okay, now I have another issue. Access icon is 15 rename 192.168.3.0. So if I give like this, it is going to accept. Guys, hello?
Yes, sir.
Why? Because I have to mention the wildcard. The 3.0 network, I don't know which subnet it belongs, slash 24, slash 25, or slash 26, or slash 27, 28, anything I don't know. So whenever writing the network, you have to give the wildcard. Remember, what? When you are writing a single network, you can give like 192. For example, here you can write list access icon list 15 deny 192.168.1.1. Okay, space. You can give like 0.0.0.0 because only a single IP. It's going to work. Or you can directly give 192.168.1.1. It's going to work. But when you are giving the network, you have to mention the wildcard mask because it doesn't know which subnet you are using, whether you are using slash 24, slash 25, slash 26, anything. Okay, so here you have to mention, since given the network, I have to mention the subnet. So what is my wildcard mark? Slash 24 means 0.0.0.255. Okay. And the last thing you have to remember is you have to give permit because other packets should access the remaining. So access icon list 15 permit enter. Now on the router I have configured. Now I have to configure on interface. So I told you guys I have to configure on the interface 0/0 because all the packets are coming inside. Okay, so this is inside. It's entering the packet and it is leaving the packet and going into the switch. So it is called as outside. Okay, so again config the which interface fast ethernet 0/0. So IP access icon group. So I'm making all this into a single group. So single group. It's already given the number 15 for this one, but I'm making all this group. Okay, and it is going to which interface? So I'm going to make this 15. So access icon group, where I have to switch this one, which access group I have to get, it is from 15. Okay, that is outside. Out. Out is outside because the packets are whatever the packets which is coming from here or here, this is called as inside. This is called as inside. But the packets whatever come inside, it will go outside. That is, it is leaving from inside of the router and it is going outside to the switch. So here I'm using outside. That's why I given outside. So let me show. Okay, it's done. Okay, now end. Okay, it's done. Now let me see whether the access icon list is there. Show access icon list. Mistake. So mistake. 10, why you can ask, sir, why it's taken 10 or 10, 20, 30 lines? Because you know the computer which in sequential order. Once 10 is done, you have to come to the second one. That's why it's taken 10 or 20. But we have taken a group as standard, that is 15. We do 3. Okay, let me try. Okay, now let me try and think. So 1.1 should not reach 2.0 network. So 1.1 should not reach, it's failed. Again, I'm going to say it's failed. Okay, now what I'm going to do, again I have another concept, that is 1.2 should not reach 2.0 network. 1.2 should not reach 2.0. Let's fail that. Okay, but here one network can able to access 3. Yes, it's because I never mentioned that 1.0 network cannot able to 3.0 network. So then I'm going to here to it's success. I have another scenario, that is 3.0 network should not reach 2.0 network. That is 3.0 network should not reach 2.0. So should not reach 3.0. We have to just put the ACL I given. 3.0, right? Okay, 3.0 should not reach the T. Yes, sorry, 3.0 should not reach 2.0, right? Sorry. But it should impact, right? It's success. But when it comes to here to here, it's from here to here, it's right. But from here to here, it's success. This is what a standard is. What it does. So, yeah, tell me.
Sir, I have one more PC from 1.1 to 3.1. How can we
What? 1.1 to
3.1, sir?
okay, you wanted to deny 3.1, correct? Right? 3.9. Okay, you wanted to deny from 1.1 to 3.1. Then you have to write one more this. That is, above this one you have to write, you have to deny any package that is deny 192.168.1.1 should not reach 192.168. Which one? 3.1. You have to write like this. You should know whether there is any other network is already there. Okay. If above what I did means, for example, if above this one, if I write deny 192.168.1.0 should not reach 3.0, then it is not going to check this one. This is not a valid. Sorry, this one, what you put is not valid. Correct, right? You already denied the whole network, correct, man? Then how can you again deny the one? Right? It is not going to work. Got it, Prakash? Got it, right? So this is yeah, tell me.
Sir, 1.1 to 3.1 data need to configure in R2 or R1? Where is it?
You have to configure here only because you know here, right? You have to configure from here. Data is traveling from here. In R2 it is going to check the AC only. That right?
Sir,
yeah. In between, whatever you want to see, here in ACL there is another disadvantages. What is that one means? Once you write any ACL Prakash, you can't able to change. Okay, you can't able to add extra things in between that one. Either you have to delete that ACL and rewrite new thing. To overcome these disadvantages, we have named ACL. In named ACL, okay, in numbered ACL, what will happen? In numbered ACL, once you write any ACL, okay, it's not going to change. Once you written, that's it. If you want to edit anything, you have to remove this one, then you have to write. And you said, sir, can I able to use this one deny? Yes, you can able to write this ACL on this one by giving another ACL number. Okay, 1.1 should dot reach 3.3.1 network, you said, correct, right? So what is my destination? That is 3.0 network, correct, right? I have to enable to this one. You can create multiple ACLs. Here, why I am showing this example, single examples, why? Because all these things network is coming inside. Yes, you can write you can write multiple ACLs. It's not a- Okay, here you can take 15, but you can't give again the 15 here. Remember, always remember, you can't give 15. Once you give it 15 here, you can give 16 or 17 there. Got it, Prakash?
So, so between another router is there. For example, phone router is there.
Hmm. Okay.
The same 2.0 network need to deny where should I need to configure this here.
For which one?
For 1.2 to 1.1 to 3.0.
1.1 to 3.0. Where it is in between here.
Yes, sir.
In between or last?
In between.
Okay. In between means you don't have to do ACL on here, not on here. What is my destination? We are going to create only one ACL, right? Okay. So you can able to create on this here only. Cross Ethernet 0/0. Because you're giving particular net this one PC. Okay. See, if you are giving a particular PC, then it should enter inside the network. Correct? Correct, right? Because it has to go to this gateway. Okay. If you are giving the whole network, I don't think it has to enter this one. Here is the serial port 0/2/0. Here only you can able to use it. Only if you are only if you are configuring for a particular PC, then you have to insert the default gateway, then you have to do it. Yeah. But you are enabling on each network, then you are even able to block here only. Right? See, when you are doing the standard ACL or extended anything, Prakash, you have to carefully do. You have to imagine what will happen if this doesn't go. In real scenarios, when we are doing the ACL, we have to check the whole network and then we have to implement. One time, what I did, I didn't give this permit any. Okay, 15 to 20 minutes, whole network was down because it only checked the ring 1, 3, 4 options only. Since 4 does not mean what will happen, it drops the plan. Got it? Thus, it didn't did like this. Got it? Right? If you are entering in your particular PC, then you have to enable on this here. If you are not entering into the particular PC or here, this is the last one. So there is nothing is there. And I disable here only. Got it?
Yes.
Okay. Okay, fine, guys. Good. Yeah. Sorry?
I can do router R2 or R3. Both are side. I can do ACL.
Yeah, you can do that one. You can implement on both the things. But you have to check where you are implementing. It does not affect the another DNA, others DNA. You have to check that one also. Whatever you're doing, Prakash, whenever you're doing, you just imagine. See, I told you here what I did. Imagine. See, I'm bringing this one. So, see, I told you one thing. See, in this scenario, what will happen? Every packet is coming inside this one network. Correct, right? But what will happen in here? Here only the 3.0. I can able to do it for 3.0 here. But what happens? All this network, even though it has to enter, right? Correct, right? So what I do instead of giving on this side or this side, I'm going on giving on this side. Why? Because there are lots of other DNA options where we are using the single PCs. So you have to think like this and you have to implement it. That is the important thing when you are doing this. Sorry, I am just here practicing for 3 networks. When it comes to the real scenarios, you have to think how it's going to. You have to check the network and then you have to do. Got it? Okay. So any questions, guys? Whether we have to follow or delete. Got it?